questions 21 through 25 on the 2006 grade 12 AMC 12A. Let S1 be all x and y such that the log of 1 plus x squared plus y squared to the base 10 is less than or equal to 1 plus log of x plus y to the base 10, and S2 be xy such that log of 2 plus x squared plus y squared to the base 10 is less than 2 plus log of x plus y to the base 10. What is the ratio of the area of S2 to the area of S1? First, let's just concentrate on S1, which is right there. So we have for S1 the log of 1 plus x squared plus y squared to the base 10 is less than or equal to 1 plus the log of x plus y all to the base 10. Okay, so if we put everything on one side in terms of just the logs, we'll get 1 plus x squared plus y squared base 10 minus the log of x plus y to the base 10, and that is less than or equal to 1. So the log rules, as I'm sure you know, state that if you have this type of a subtraction, you can divide them. So it becomes 1 plus x squared plus y squared divided by x plus y all to the base 10 is less than or equal to 1. Now, if this is the case, then that means that 1 plus x squared plus y squared all over x plus y is less than or equal to 10 to the power of 1, which is 10. Okay, now we continue. The log is gone, so we can just use the numbers. X times 10 plus 10y, like that. Now, this reminds me of a circle, or the equation of a circle. So in order to get that, I have to bring everything over to one side first. So I'm going to do that. Y squared minus 10y plus 1 is less than or equal to 0. But in order to get it into the equation of a circle form, I have to complete the square. So remember how to complete the square. You take half the coefficient in front of x and square it. But then, of course, I have to subtract it as well. And very same thing for this part of the equation. So this part and this part factor. So this becomes x minus 5 squared, and this becomes y minus 5 squared. And now we've got minus 25, and 1, so that's minus 49. Put that on the other side, and there you go. We've got a circle. And in particular, everything inside the circle, because it's not just equal to, it's less than or equal to. So this is essentially a circle. If you remember, this is r squared, right? Because the circles are always of the form x squared plus y squared is equal to r squared. And in our case, our circle has the center 5, 5. That's why it's minus 5 and minus 5. So this is a circle of radius 7. So its area will be pi r squared, and the radius is 7, so its area will be 49 pi. And that is S1. So in an almost identical way, we will proceed with S2. So here we go. Log of 10 2 plus x squared plus y squared is less than or equal to 2 plus the log of x plus y to the base 10. So put everything on one side as before, and you'll get log base 10, 2 plus x squared plus y squared minus the log of x plus y to the base 10 is less than or equal to 2, like that. So this becomes the log of 10, 2 plus x squared plus y squared over x plus y, like that, is less than or equal to 2, and therefore 2 plus x squared plus y squared all over x plus y is less than or equal to 10 to the power of 2, which is 100. Okay? And now in a very similar way, we are going to continue with this to try to make it into the equation of a circle. 2x squared plus y squared is less than or equal to 100x plus 100y. And then put everything on one side. X squared minus 100x plus y squared minus 100y plus 2 is less than or equal to 0. Now we're going to complete the square. So just as before, take half the coefficient, which in this case is minus 50, and square it. So that's going to be 50 squared. And then subtract 50 squared. And same thing over here, 50 squared. And subtract 50 squared. Okay? So this part factors x minus 50 all squared, and this part factors y minus 50 all squared, and then we've got a minus 50 squared plus 2, minus 50 squared plus 2. So that's going to be 50 squared plus 50 squared minus 2 if you put it all on the other side. And this looks like, what, 2,500 plus 2,500, 5,000 minus 2. So 4,998. Okay, so that means this is a circle. Everything inside the circle also, because it's less than or equal to. And this time the radius squared is 4,998. So S2, the area, is pi r squared. And r squared is 4,998. Pi. So they want the ratio, what was it, of S2 to the area of S1, okay? So S2 over S1, so that's going to be 4,998 pi over 49 pi. The pi's cancel. 4,998 divided by 49 is 102. So there you go. That is the answer, and that would be, for number 21, E. A circle of radius r is concentric with and outside a regular hexagon of side length 2. The probability that three entire sides of the hexagon are visible from a randomly chosen point on the circle is half. What is r? So here is a diagram of this question. We've got this regular hexagon in the middle, and there's a circle that is concentric, meaning it shares the same center, and it's obviously around this hexagon. And they're going to choose any point at random on the circle, and from that point they're saying that three entire sides of the hexagon will be visible. All right, so how do we approach this problem? So the key to understanding this question is to first realize that if you are on the circle at any point, you have to be able to see three sides. So that means, for example, if you are here, right at R, that will be possible. You will just be able to see side BA. And of course you'll be able to see side CB, and you'll definitely be able to see sides CD. But if you start going over here, then you can't see BA anymore. And similarly, as you go across that circle like that. Now, if you're at R, you can. And if you continue on the circle like that, you can until you get to Q. Q gives a very similar story in that if you're at Q, you'll be able to see CD, you'll definitely be able to see CB, and you'll definitely be able to see BA. But once you go past Q, you can't see CD anymore. So now you can't see three sides. So that means the only place in this diagram that you can see all three sides, or three sides, is between R and Q. Right there, that arc. If the point, the randomly chosen point, is on that arc, you'll be able to see BA, BC, and CD, and those are three entire sides of the hexagon. Okay? Now, the important thing to remember is that RQ is not the only place on the circle. That's one place, one of 6 arcs. So within arc RQ lies a point from which 3 sides of the hexagon are visible, and there are 6 such arcs. We just drew one, but you can find the same type of arc if you were to look at it from the perspective of BA. It would be kind of here, and then similarly there'd be another one here, there'd be another one here, here, and here, approximately. So 1, 2, 3, 4, 5, 6 arcs. Okay? That's the first part of the question. Now they're telling you that the probability of you being able to see 3 entire sides is a half. Okay? So how do you interpret that? What that basically means is that those 6 arcs make up half the circle. So the 6 arcs equal half of the circle's angles. So what that means is that if I were to draw a line from O to R and O to Q, like this, that would create an angle, of course, from here to here. Let's call that theta. Each of those arcs has a associated angle, and since we have 6 of them, if you add up those angles, they will equal half of the circle, half of 360 degrees. So 6 theta equals 180, and therefore theta is 30. Okay, so this is 30 degrees. So a very important part of the question right there. Okay, so far so good. Now, we have to figure out what is R. R is the radius, correct? And we are told that the hexagon has a side length of 2. Okay, so I'm going to draw one line from O to C, like that. And that's going to help me figure out R. Now, I'll draw one more line from O to B, and this is only to illustrate the following concept, that this triangle right in here, CBO, is equilateral. Okay? Why is it equilateral? Because they all have 60-degree angles. If you were to draw a line from D to A, you'll see that it splits that hexagon into triangles, and each of those triangles has 60, 60, 60 as each of its angles. And there's lots of ways of proving that. For example, one way is to understand that internal angles of a hexagon are equal to 120. So from here to here is 120. So each of those, since we're slicing the angle in half, is going to be 60. Now the reason that is important is because it helps us know the side length from C to O. Because the hexagon has a side length of 2, if CB is 2, then CO is 2. All right? So I'll just write 2 right there from C to O. And I can write that here also, CO equals 2. Okay? And then in this diagram, OQ represents the radius of the circle, so I'll call that R. All right? So we are going to use the law of sines to figure this out. Now, to figure out the law of sines, if you're not familiar with that, which I certainly hope you are, if you have a triangle, let's say A, B, C, and this is the length C, length B, and length A over sine A is equal to B over sine B is equal to C over sine C, like that. Now we're going to do that on this triangle right here. Triangle QCO. That one right there. All right? Now, of course, in order to use the law of sines, we need the angles. We need this angle right here. And we also will need this angle right here. So let's try to figure out those angles. Well, this angle in here is 60 degrees. We know that. And therefore, this angle, all the way from there to there, has to be 120, since 60 plus 120 is 180. And angles about a line are always equal to 120. So that is 120. Let me just put that in there. And then this angle in here, from there to there, well, that's basically going to be 45 degrees. Now, you say, well, how do you know it's 45 degrees? Well, remember theta we calculated as 30, right? So this guy in here is 30 right there. And this thing, or this angle I should say, that's 60, right? Because it's part of the equilateral triangle. So that means that each of these little guys in here, if you can see it, on either side of that theta, is going to be 15 each. There you go, those little guys. So one little guy plus the theta is going to be 15 plus 30, which is 45. Okay, so that means this in here is 45, and therefore if you do the subtraction, this is 15. All right, so there we go. We've got our angles. So let's use the law of sine now. 2, this 2 right here, over the sine of 15 is equal to r, which is this distance, radius, over, which angle are we going to use? 120. So there you go. That is the equation that's going to help us solve for r. Now it seems like immediately you can get the answer with a calculator, right? Piece of cake. We only have one variable, and sine of 15 is a number and sine of 120 is a number. But unfortunately, because we are not allowed to use calculators on the US exams, we still have significant amount of work to do to get the value for r. Well, it shouldn't be so bad. Sine of 15 times r is equal to 2 times the sine of 120, correct? Well, the sine of 120, you should know, is root 3 over 2. That's one of those angles that you should have memorized. So that's relatively straightforward. But unfortunately, we got to figure out this sine of 15. Okay, well, you don't have a calculator, so I guess we have to use some of our laws here. Sine of 15 is really the sine of 45 minus the 30, right? 45 minus 30. And this is the expansion rule. Sine of 45 cos of 30 minus sine of 30 cos of 45, like that. So this is root 2 over 2. These are the ones that you're supposed to have memorized. 1/2 and root 2 over 2. So this basically becomes root 6 minus root 2 over 4. All right, we're getting there. So go back and plug this in here. Root 6 minus root 2 over 4. So r looks like, well, that one looks like the root 3 just becomes by itself. And then unfortunately we got this root 6 minus root 2 over 4. Okay, invert and multiply, and we'll get 4 over root 6 minus root 2. And most likely they're going to rationalize the denominator. So we have to multiply top and bottom by root 6 plus root 2, like that. And if we do, let's see here, this gives you 4 root 18 plus 4 root 6, and then the bottom becomes 6 minus 2, like that. So 6 minus 2 is 4, so that just becomes root 18 plus root 6. And anything else we can do here? 18 is 9 times 2, so that's 3 root 2. And that's it, root 6 by itself. All right, finally, there we go. And that is R. 3 root 2 plus root 6. So that would be 3 root 2 plus root 6 for number 22 is D. Given the finite sequence, S is equal to A1, A2, dot, 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 all the way till AN of n real numbers. AS be the sequence A1 plus A2 over 2, A2 plus A3 over 2, dot, 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 AN minus 1 plus AN over 2 of n minus 1 real numbers. Define A1S equal to AS, and for each integer m with m between 2 and n minus 1, define AMS equal to am minus 1s. Suppose x is greater than 0, and let s equal 1x, x squared all the way till x 100. If a100s is equal to 1 over 2 to the power of 50, then what is x? All right, first let's try to understand this question. What's going on? What's happening? All right, well, first and foremost, they give you this set. So they tell you that s is 1x, x squared, x3, and so on, right? All the way up till x to the 100. And then they tell you that a100s is equal to 1 over 2 to the power of 50. Now that is meaningless to us at this point in the question. So we won't worry about that. But what we will concentrate on is this right here. Okay? So I'm going to start with A1. A1S. And then I'll do A2 and then A3 and A4. And I think hopefully by then I should be able to get some sort of a pattern. Okay. A1S is just equal to AS. They tell you that. And AS is this equation or system or sequence or whatever you want to call it. All right, so here we go. How do we get AS? Okay, don't be intimidated. Don't give up and just go to the next question. Work with this. I encourage you. So, how do you get it? It's the first term plus the second term divided by 2. So, the first term plus the second term divided by 2. So, 1 plus x over 2. Okay, next we get to A2 plus A3 divided by 2. So the second term plus the third term divided by 2 would be x plus x squared over 2. All right? And so on and so forth. So I'll just do a few of them. X squared plus x3 over 2. X3 plus x4 over 2, and it kind of goes on from there. All right? You get the point. All the way until x to the 99 plus x to the 100 all over 2. Okay. And what I'm going to do over here is I'm just going to write the number of terms. I just want to put that in there. And for the first one, right, how many terms do we have if we had to count them all? Well, we've got 100. 100 terms. So I'll just put that in there, 100. Squeeze it in there right there. That will make a little bit more sense later as to why I did that. All right, let's turn our attention to A2S. Okay, so again, attempt it. Don't get discouraged. Don't get intimidated. Same formula right up here. A1 plus A2. So this time, this is my first term. This is my second term. So 1 plus x over 2 plus x over 2 over 2 all over 2. Okay? That's the first one. Second one, the same way. X plus x squared over 2 plus x squared plus x to the power of 3 over 2, all over 2. Correct? Following? No problem so far? All right, here we go. Keep going here. I'll just do, what should I do? One more? I think one more should be sufficient. So the next one, let's see here. It's x squared plus x to the 3 all over 2 plus x to the power 3 plus x to the power 4 all over 2. And so on and dot, dot, dot. Okay, keeps on going like that. And this has 99 terms. All right, remember I wanted to put in the terms. All right, now let's go to A3. I think by now you're getting a little bit of the hang of it. So this now, we have to add these. But before I put in A3, I'd like to simplify this a little bit because this is kind of messy. This is going to be 1 plus 2x plus x squared. And that's all over 2, which is all over 2. So it's actually all over 2 squared. And then this is x plus 2x squared plus x to the power 3, all over 2 squared. And this is x squared plus 2x to the power 3 plus x to the power 4. Oh, forgot the 2 there. So that's all over 2 squared. And this kind of keeps on going, dot, dot, dot. All right, now I'm ready for A3. So here we go in a very similar way. The first one plus the second one. So that's going to be 1. I'll just simplify it immediately. 3x plus 3x squared plus x to the power 3 all over 2 squared all over 2. So it's 2 to the power 3, right? I just saved a step there. And the second one, x plus 3x squared plus 3x cubed plus x to the power 4 all over 2 squared, which would be 2 to the power 3, dot, dot, dot. And this has 98 terms. So put that 98 in there, number of terms. And I'll just do one more, and then we'll go back and look at this and see if there's any kind of a pattern. A4S. All right, A4S, obviously we're going to add these two, so it'll be 1 plus, let's see here, 4x plus 6x squared plus 4x to the power of 3 plus x to the power of 4 all over 2, all over 2 to the power of 3, which will be 2 to the power of 4. And then dot, dot, dot. And this has 97 terms. Okay, now let's go back and look at this from the perspective of pattern finding. So A1S, this is my first term. Okay, doesn't really help me in any way. A2S, this is my first term. All right, that looks very familiar. It looks like x plus 1 all squared, well, obviously over 2 to the power of 2. Okay, this was x plus 1 here over 2. This is x plus 1 squared over 2 squared. All right, let's go to the next one. This is the first term. This is x plus 1 to the power of 3, all over 2 to the power of 3. And then if we look at a to the 4, and look at that first term, that is x plus 1 to the power of 4, 2 to the power of 4. Okay, I got the pattern. The pattern, basically, is that ANS will be x plus 1. The first term will be x plus 1 to the n all over 2 to the n. And these terms, the number of terms that I drew here, that's important. Very important, actually. Because here it was 100, 99, 98, 97. But what about n? If it's an, how many terms? It's 101 minus n. Okay, it's not a genius to figure that out. I mean, I just looked at the pattern. Right? It fits. So, we are interested in A, if you remember, 100s. That is what they were asking us. Okay, well that's going to be x plus 1 to the 100 over 2 to the 100. Okay, and what's interesting about A 100s, how many terms will there be using this formula? 101 minus n, which is just one term. This will only have one term. And that one term, if you were to make a list, it will be this guy right here. That's the only term. X plus 1 over 100 over 2 to the power of 100. And they tell you in the question right here that A100s is equal to 1 over 2 to the power of 50. So this is equal to 1 over 2 to the power of 50. All right, I can figure this out now. So here we go. X plus 1 to the power of 100 over 2 to the power of 100 is equal to 1 over 2 to the power of 50. Correct? X plus 1 over 100. I'll put this guy up here. So that'll be 2 to the power of 100 over 2 to the power of 50. So x plus 1 over to the power of 100 is equal to 2 to the power of 50, right? Because it's 100 minus 50. And then I'll put this in terms of squared all to the 50, making the exponents the same. That's perfectly allowable. And since the exponents are the same, I can just concentrate on what's the base. And the bases are just x plus 1 squared on that side and 2 on that side. And then this becomes just x plus 1 is equal to the square root of 2, right? Take the square root of both sides. And finally, x is equal to root 2 minus 1. There you go. Pretty cool, right? It's a good question. So x is root 2 minus 1, and therefore number 23 would be choice B. The expression x plus y plus z to the power of 2006 plus x minus y minus z to the power of 2006 is simplified by expanding it and combining like terms. How many terms are in the simplified expression? X plus y plus z to the power of 2006 plus x minus y minus z to the power of 2006. Well, to make our lives a little easier, I will let y plus z equal a. Okay, makes it a little bit simpler to handle when we do this expansion. So therefore, this becomes y plus z substituted for a, x plus a, 2006, plus x minus a to the 2006. Okay? So that is what we are going to expand using, of course, binomial theorem. And here we go. I'm not going to do it all, of course. I mean, that would be crazy. I'm just going to do, I don't know, 8 terms maybe. I think 8 should be enough. A1 x to the 2005 plus A2 x to the 2004 plus A3 x to the 2003 plus A4 x to the 2002 and ... plus I'll do, I guess, until the last 4. I did the first 4, I'll do the last 4. So a to the 2002 x to the 4th plus a to the 2003 a to the 3rd plus a 2004 x that should have been an x. X squared plus a to the 2005 x, and then finally a to the 2006. All right, now that's this guy right here, what I just expanded. So I'll put that in brackets, and then I've got to add to it this one expanded. Okay. All right, let's do that one. So we got x to the 2006. Now it's not identical because we've got x minus a this time. Yeah, the first one was x plus a, and this is x minus a. So it's a slightly different. Minus a x to the 2005, right? Plus a squared x to the 2004 minus a to the third x to the 2003, and then plus a to the fourth x to the 2002, like that. Plus dot 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 plus, and then we're going to do the last four. So plus, this was a plus up there, a to the 2002 x to the fourth minus a to the 2003 x to the third plus a to the 2004 x squared minus a 2005 x plus a to the 2006. Okay, here we go. Now the good news is we collect like terms here, and we can do it without, of course, doing the full expansion, because that would be, take forever. Now watch what happens here when we add this guy and this guy. Okay, great. That's 2x to the 2006. And then the next one cancel. So those are gone. Then we add these two. So that becomes plus 2a2 x to the 2004. And then the next one, which is this and this, cancel. And then we add the next two, which is that. So that would be plus 2a to the fourth x to the 2002. And I think you're getting the hang of this by now. So I'll just finish it off. Plus dot dot dot, like that. And then look at the last few ones. Let's look at it from the very end. That is going to not cancel, so I'll keep that. 2a to the power of 2006. The second last one, which is this one and this one, those cancel. The third last one does not cancel, right? So you get two of those in our final sum. So plus 2a to the power of 2004 x squared. And let's see here. This one cancels with this one. And then these two will add together. So that becomes plus 2a to the power of 2002 x to the fourth. And this was dot 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 like that. Okay? So we got it all the way down to here. We got a pretty decent pattern here. But remember, we had let a equal to y plus z. So it's not as simple as it looks initially. But that's not too much of a problem, because if you were to put this to any kind of exponent, also by the binomial theorem, each of these will give n plus 1 terms when expanded. So what that means is that will help us figure out how many terms are in each of these components of this big long equation. All right, the first one's relatively simple. That's just one term right there. Now this guy right here, a squared. A squared, the n is 2 this time, so it would give us 3 terms when expanded. So this basically gives me 3 terms when it's all expanded. How about this one here? Well, it's a to the 4th, n is 4 this time, so that means using this, it'll give me 5 terms when expanded, and so on. When we get to here, it's a to the 2002, so that gives me 2003 terms when expanded. This gives me 2005 terms when expanded. And finally, that gives me 2007 terms when expanded. And our job in this question is to figure out the total number of terms. All right, now it just boils down to adding these numbers. Okay, we can do that. 1 plus 3 plus 5 plus ... 2003 plus 2005 plus 2007. So this is the total number of terms in our expansion. Okay, well at this point, whatever way you want to do it. I like to do it in the following way. How many numbers are there, first of all? Well, there's 1,004 numbers. So there's 1,004 numbers here. And I'll group them. 1 plus 2007, the first and the last. 3 plus 2005, the second and the second last. 5 plus 2003, the third and the third last, ... right? Now I group them. So how many pairs do I have? Well, 502 pairs. And each pair looks like it adds up to 2008. Correct? So I've got 502 pairs. Each pair equals 2008. So this therefore becomes 2008 times 502 when you do the addition. And that is equal to 1,008,816. So there you go, 1,008,016. That would be for number 24, choice D. How many non-empty subsets S of 1, 2, 3 until 15 have the following 2 properties? Number 1, no 2 consecutive integers belong to S. Number 2, if S contains k elements, then S contains no number less than k. So first, let's try to understand this question. What is the question telling us? Well, let's start with the point 2 first. S contains k elements, then S contains no number less than k. So for example, let's say k is equal to 1. If S contains k elements, that means S contains 1 element. And S contains no number less than k, so S contains no number less than 1. Well, there is no number less than 1, so it looks like the set will be any of these numbers. All right? So from those numbers, you can choose any of them and choose one number as your set. All right? So for example, if I chose 1, that's it. That's my set, because I have chosen k to be equal to 1, so that means the set contains only 1 element. And I can choose from any of these numbers because I didn't have to eliminate any of these numbers, since when I say that the set contains no number less than k, well, there is no number less than k because k is 1. So for the first scenario, k equals 1, how many ways can I choose a number? Well, it's from 15 numbers, choose 1. And I hope you know how to do this. If you don't, I'll just remind you it's 15 factorial, 15 minus 1 factorial times 1 factorial. And this is equal to 15. Okay, so there you go. That's for k equals 1. Now when k equals 1, what did we have for n? And n refers, in my example, to how many numbers do we have to select from? Well, we had the full 15 because we didn't eliminate any. All right? So that takes care of k equals 1. Let's go to k equals 2. All right, same kind of story, k equals 2. And before I get to k equals 2, let me just talk about point number 1 when k is 1. No two consecutive integers belong to S. Well, we only have one integer in there, so there's no real issue with regard to consecutive integers. It will become an issue when k equals 2, and that is what we're going to talk about now. So when k equals 2, the set now contains 2 elements, right? K is 2. And S cannot contain any number less than 2. So that means my set cannot have the 1 in it. So I can only have 2, 3, 4, up until 15. All right. So now my set has 2 numbers in it. Okay. I'm going to choose one number, and then I'm going to choose another number. And now I have to be concerned with my first rule, which is that I can't choose consecutive numbers. Okay? So that's very important. So, how do I do that? Well, let's do it in the simplest way possible. I'll choose 2, and then I can't choose 3. Why? Because remember rule, no two consecutive integers. So I've got to choose maybe the 4. All right, that is one way of doing it. That is according to the rules of the question. Now notice, after choosing my 2 numbers, when 2 numbers are chosen, we skipped over one number, correct? The one number we skipped over in this case was 3. So we chose 2 numbers from really the remaining 13. From these 13 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So mathematically, what that really means is that from 13, choose 2. And 13 choose 2 is equal to 13 factorial over 11 factorial over 2 factorial. And that is going to be equal to 78. All right. So I hope you get the hang of it. And just to be complete, what was n in this case? N I'm representing as the number of numbers in my set right here. Well, I believe in total it was 14. Okay? So, hopefully you're getting the hang of this. Let's keep going here. So now let's let k equals 3. If k equals 3, remember we can't have any number less than k, so we can't have a 1 or a 2, but we can have everything from 3 to 15. So let's write n in here. How many numbers are there that I can choose from this time? It looks like 13. Okay, so my set now is going to have 3 numbers in it. So I've got to choose 3 numbers. All right, let's do this in the simplest way. Choose a 3, 3 goes here. Can I choose a 4? No, because I cannot have digits that are consecutive, right? That's one of the rules. No two consecutive integers can be chosen. All right, I can choose a 5. That's perfectly fine. Can't choose a 6, but I can choose a 7. All right, this is just one way of choosing it. And in a very similar way, when k equals 3 numbers are chosen, we skipped over 2 numbers. And those numbers in our example was 4 and 6. We skipped them over, right? We can't choose those because it would violate the terms or rules of the question. We therefore chose 3 numbers from the remaining 11. So mathematically, that means from 11, choose 3. And 11 choose 3 is 11 factorial over 8 factorial over 3 factorial. And the numerical value for 11 choose 3 is 165. Okay? So far, so good. Hopefully you're following. And the good news is we've only got 2 more. And then our rule ends. And without going through this entire thing, I think by this point you get it. So for k equals 4, n would equal 12. We only have 4 to 15 as our choices. And we're going to choose 4 numbers this time. And in a very simple way, we can choose, say, 4. Can't put the 5. We got to skip over that. We can put a 6 here. Can't put a 7. But we can put an 8. Can't put the 9, but we can put the 10. So we skipped over the 5, the 7, and the 9. So when k equals 4 numbers this time are chosen, we skipped over 3 numbers. It was the 5, the 7, and the 9 that we skipped over. So essentially we chose 4 numbers from the remaining 9 numbers. And those 9 numbers are, of course, 4, 6, 8, 10, 11, 12, 13, 14, 15. And therefore, mathematically, that is from 9, choose 4. And I'll just give you the numerical value. It's 126. K equals 5. This is the last one, by the way, just in case you're wondering. K equals 5. This time we have numbers from 5 to 15 as our choices. And in a very similar way, we are now going to choose 5 numbers. And we can do them in lots of ways, but I'll just give you one. Let's say I chose a 5 here, 7 here, 8. Can't choose the 8, right? Because that's consecutive. 9, 11, 13. That's all fine. But then if I did that, I had to skip over the 6, the 8, the 10, and the 12. So when k equals 5, we chose, of course, 5 numbers this time for our set. And we skipped over 4 numbers, 6, 8, 10, and 12. So essentially what we did was we chose 5 numbers from the remaining 7. And those 7 numbers were 5, 7, 9, 11, 13, 14, 15. So mathematically that means from 7 choose 5. And that is equal to 21. All right, how about if k equals 6? Well, the good news is we don't have to do that. Why? Well, let's see. If k equals 6, our set is between 6 to 15 in terms of what we can choose from. And there's no way for us to make rule number 1 work. Watch what happens. Let's say I put the 6 here. Can't put a 7, put the 8 here. Can't put the 9, put the 10 here. I can put a 12. I can put a 14, and then there's nothing. I can't choose any number now. If I put a 15, I violate the rule. If I put any other number in here, like let's say 11, well, I've got 2 consecutive numbers. So when k equals 6 or greater, k greater than or equal to 6, we can't meet the criteria. So I think we've got it all. We only have to figure it out for k equals 1, 2, 3, 4, 5. So what did we get? For k equals 1, we got 15. For k equals 2, we got 78. For k equals 3, we got 165. For k equals 4, we got 126. And for k equals 5, we got 21. So we've got to add up 21, 126, 165, 78, and 15. And this adds up to 405. So number 25, the answer is E.